now onto the kind of main second part of the workshop, which is we've covered all the basics, we've covered looping, we've covered printing. Now we're actually going to do stuff and how you structure your macros. So you typically, in my experience of 10 years or so of writing Fiji macros, they all boil down to about the same thing. You're going to kind of have some location where you've got all your images. You're going to generate somewhere where to put them. Now, you always want to do that in a separate spot, because otherwise I've seen Fiji kind of just keep going. And if it opens an image, saves an output, it'll then eventually open that output and then just go on forever. So having a separate spot, like a separate folder, is quite useful. And then you're going to actually do something. So you'll open the image and hopefully make a measurement, do some modifications, whatever. Get those measurements stored into variables and then save everything out into tables, spreadsheets, output image files, and some kind of log file so that you know what was done. So I like to begin this scripts with some kind of like resetting of your workspace, which is, I've had issues before where, if you've got a file that's open already and then you're trying to open something else, it can get confused. So I normally have this, while number of images is more than 0, just close everything. Clear results is quite good because you don't want anything in your results table. ROI manager reset, it gets rid of anything in the ROI manager. So then you're kind of getting a bit of a clean slate to begin with. For the file paths, it tells the program or Fiji, where to look for your images that you're going to process. So if I had a folder on the desktop called images, hopefully your experiment data structure is not that kind of bland, but the path would look like this, right? So probably something like obviously Windows bias, but on the C drive, under the users folder, under the user name that you've logged in as, desktop, and then images, and then you'd have something called image.tif or .czi, whatever. For anyone computationally inclined, if you have Windows versus Mac, the slashes go opposite ways. Nice and fun. So instead of having hard to find slashes, you can use this file.separator. And I populated as something called fs, and then I would build my path like this. So then it doesn't matter if it was open on a Mac or a Windows, assuming that they were also on a desktop on a Mac. But it stays the same or true for like if you have path and then you define some location, and then within that folder you want to make a new directory, you would need to put a slash to go down another level. So, that's one way of kind of hard defining the path, but you'll probably, for more convenience, use this command get directory. And then that will use the operating system's dialog to then navigate to a folder. And you can see what's printed there. So once you've got a location that you can store or that you've got your images in, you can kind of look in there and get the list of files that are in that directory. So if we have this path equals get directory, pops up, you navigate to a folder, and that has some kind of string, you can say, well, the file list is to get the file list command of path, so it will kind of tell us what's in the folder. And it creates an array that you learned about last week, where it lists everything in there. So this would be like array value 0, 1. So then you can say, well, the number of files is whatever's this file list, which is an array, and then we can query arrays by just depending onto its dot length, and that tells you how many things or elements are in that array. So then you can kind of say, for the length of how many files there are, go through each one, we learned about the loops, to get the file name. And so what would happen is we've printed the path, that's that. We counted the number of files using the file list, get file list, so it says number of files that equal 3. And then I loop over each one, printing their name. And that's a new command as well, the file.getName. But hopefully that makes sense. And I mentioned before that you might want to make a new directory or a new folder. So depending on what you're doing, what your script's doing, maybe you want to write a little batch script that takes every image and does a max projection and a sum projection. And for sanity, you might make a folder in the output called, these are my sum projection ones, and these are my max projected images. So you want, there's many reasons you might just make output directory. So what I would normally do is you've got your path that's defined. You can say that my results directory just equals that location plus underscore results. Now, the path that it got before ends with a slash. So I don't need to add another, file separator. So I put an underscore because in the operating systems, underscore puts that at the top. So underscore becomes before A. So then like alphabetically, it's just at the top. So there's been so many times I've had a folder of like 1,000 images, scrolling all the way to the bottom just to get the results directory is kind of annoying. Underscore it goes to the top. And so we use this command file.make directory, and that will make a folder according to the operating system at that location. So the first kind of warm-up exercise is to define some input location, print out that location, print out how many files are in it, which hopefully you've seen on the previous slide. The commands are there. It's nice and easy to get warmed up. But the bonus stuff is put a date and time in the output directory name. And the reason why I like to do that is if you run the script and it crashes, and it's already made a directory called results, and then you go and run it again, it's going to get confused when you ask it to make that thing that already exists. Now, a lot of languages will just kind of go, that's nice, that's fine, I'll just carry on, it's already there. I've seen in Fiji it crash when that happened. So ideally, you want something that would be like a unique file name every time you run the script. And then that way, once you're debugging, you don't have to keep going back and deleting the folders that it crashed on. Because if you have had experience coding, often when Fiji crashes, it doesn't unlock the file again. So when you go to delete it, your operating system has a warning going, I can't delete that because it's in use at the moment, because Fiji is still kind of holding on to it, even though the script crashed. So put the date and time in. And then the bonus is, the second bonus is that the directory also has some other stuff. That might be a metadata file. It could be anything that's in your folder, basically. So some of our microscopes spit out like a .txt file, some it's a .xml. So you generally want a way to try and not or identify what's at the end of the file name. So I'll give you a little hint that there's some string kind of commands, starts with and ends with. That can help there. But have a go. So then we get the file list of the path and we print that out, and as usual, we did that. Then I run a get date and time so that I've got the information to populate my results directory. So here I add the date. So it's results. Remember that this would resolve to like blah, 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 my image location / and then we make the new path that will be results underscore means it goes at the top, and then the year, the month +1 because why, and then day of month, and then at some hour, minute. You're probably not going to run your script faster than once a minute, but if you are, then you would also just add second. And then I finish this like path string with a /. Now, if I was good, I should put the file separator thing. That's just me being. And then I'm going to make the directory of that, and it will build that. And now you may have done this a different way, but the way I approach it is I set some variable to say, is this an image? And I set that to be false. So then I go to the file list, remembering that the file list, I can probably get it on the background here. Also, apologies if you got exercise 5 and 6 answers. So what I would do is say there's 5 or whatever files there was when I ran it the first time. So I get the current image, I get its name, which will be just whatever iteration of the loop of the list, and then I say, does it end in TIFF? And then if it does, if it ends in TIFF, then I change the state of image by saying is image equals whatever it currently is plus 1. Because I'm just counting, right? So I just want to add 1 to whatever value. And I could put plus plus, like we learned as the increment decrement thing, like in the list up here. So then I just will run this for each time, and it will say, does that end in TIFF? Yes. Does that end in TIFF? Yes. Does that end in TIFF? This one, it doesn't, so it won't add anything, and then it won't add anything, and then it will say at the end, you know, there is or are however many files ending in TIFF. Prints that to the log window, and then I save the log window. That little snippet to show you how you would save the log window, and it would print it all out. Before, we weren't actually opening the image files, right? We were just getting their name as a string. But when you come to writing your own scripts, you're obviously going to want to open the file and do something to it. So there's multiple ways in Fiji that you can open a file, and it will trial its different ways. So like if you open a CZI file, it's going to try and use bio formats. If you open a TIFF file, it'll probably just use the standard opener. You could force it to open that TIFF file with bio formats though. So there's many ways to kind of get there. You could just run this command open, and then like the path to your images plus, you know, whatever index of the array of files it's going to do, and it'll open, right? Or you could run this big long command, which is bioformat. So who's opened a bioformat image before? Between most people. You get that pop-up. Now, most of the users that I've worked with over the years just click OK and never do anything with that. They never even thought about it. But there's a lot of different things you can do. You can choose to open the image as a hyperstack. You can choose to open it as single channel being displayed, composite displayed, all different things. So what this does is it calls bioformats, and it's going to open some path for the file. It's, you know, it's the same thing here. A location to a file would be a better way to describe it. And I'm going to auto scale it, set the color mode, that's your composite grayscale color, just to be default, so whatever the file recommends. If there's ROIs, import them. So like if you captured on like a Zeiss confocal and you've drawn a bleach region, Fiji read all that and bring that in. We want to view hyperstack. So some of the other options are like just view the metadata. So when I open the files, we can do that. And I've got a defined stack order. That's normally double check. Couple of things. So you can change these arguments. There's a whole lot of documentation on bioformats. Kind of read it on your own, but that'll get you started with most things. You may have to change this if you've got a microscope that's storing files with series. So, you know, sometimes you open up your bioformats, it says like, do you want to open series 1, 2, 3, 4? Whether they're resolution pyramids or whether they're, you know, if it's like a Leica, you tend to have like the multiple files stored in the list file. So you may need to tell it open all, there's a series underscore all, or, you know, series 1, or you open all of them and then search for a window called series 0. That's how you approach it. The other thing is people tend to put spaces in file names, whether it's the microscope or the user, spaces in file names, strange characters, percentage symbols, things like that might break this string when it resolves down, because if there's a big space in the middle, it's going to stop early and prematurely. So we wrap the open around these square braces, and then that kind of fixes any issues you have with spaces. So if you just run like open by, if you have the recorder running that I showed you earlier, and you drag the file on bioformats, it won't necessarily have those. They don't break anything, but they do fix if you have spaces. Knowing the current image title is really important. So once you do open stuff, there's this, what do I say, select window is quite good. So once you kind of have the get title, you might also want to go and select that one. So what I do normally in all my code is have this window title equals get title. So then I know this is basically the current file as to how Fiji views it. And then if I want to select that later on, I could do select window, window title. And if I run split channels, for example, or if you do like a projection, you'll know that it says like max underscore and then the window name. So you can say split channels, select C1 hyphen and then the window title. And then I might rename that colloid nuclei, whatever I'm doing in my script, right? Rather than always referring to that, because when you're 100 lines in and you start going, what was C1 again, or whatever, or the user, if the users come to you and said, oh, my script, that you wrote, it works fine, except I'm now capturing this other channel and the nuclei channel is a different number. So you can have ways that you can capture that and know that. Something that you may notice with a lot of my code is I'll always use the same thing. So if I write code for one person and then 3 years later write code for someone else, I always try and use the same variables that are like the generic ones, because you're just going to kind of copy paste your code from other bits, right? And so if you know that you always call it the same thing, it'll save future use some time. Bit of a tip. But there's one extra slide before I get into the point I'm trying to make there. But basically, if you're consistent, it'll make your life easier. Another useful thing, once you've opened images and saving stuff, it's pretty simple in Fiji. To save it, you just specify the file type and then you give it the path. You can't save out as CZI because that's license proprietary or LIF or whatever. So you generally save it as TIFF. I always recommend using double F. Who knows the difference between TIF and TIFF? Anybody? There is a difference. Who saved the file and Fiji's throwing up a warning going, your image is bigger than 4 gigabytes. It may not have worked. So that's TIF. We call this one big TIFF. At some point, they realize the files are going to get bigger than 4 gigabytes. So saving that one, you don't get that warning. Nowadays, it's pretty universal to work with either format, but that's the difference. So here I'm going to say save as TIFF. Now, I haven't kind of shown how you would resolve this, but we should know that this is probably some folder called results underscore date and time, right? That's just my format. I haven't introduced this yet, but down here I do. So let me skip down here. So when you're saving stuff out, you generally don't want to have something called, my image.tiff.tiff.tiff, because that can happen with Fiji if you keep duplicating and saving stuff. So what I normally do is I use this replace string where I say, get the file name, and then I make one where I would strip away the TIFF. And so then I have window title, no extension. So when I save out my TIFF here, I'm going to use, my image without the .tiff. And then I'm going to give it some kind of what I did. Let's say it's the red channel mask or the output or whatever you want to call it. And so this will kind of iterate over each image, because earlier in the script, we would have had what the file name is, but this will stay static. So if you have like 3 images, image 1, you'll get an output called image 1 underscore red mask, image 2 underscore red mask.